right, now we'll try it again. Now we'll see if it goes 10 times. All right. So we're going to take, there's 4 kinds of conic sections. Okay? We've done all 4 of them. We started with parabolas. We did those a couple weeks ago. Then we went to circles. Then we went to an ellipse or ellipsi. Okay? And then last week we did hyperbola. Okay? So we got the 4 kinds. Today and this week, what we're going to do is we are going to have just equations written out. Okay? And from that, then we're going to have to determine what is what. What makes a hyperbola, what makes an ellipse not a circle, what makes a parabola be a parabola and not any of the other ones. Okay? So we're going to do that. So today is important for that. Tomorrow is extremely important for that because I'm going to have a video on completing the square. And we need to have a completing the square video in order to be successful Wednesday and Thursday and on your final. There is questions from this particular week on your final. Okay? We will tell you that on the NTC final. We had to do all of that to get to this week. Okay? So there's that. Okay? And then we'll go from there next week. Okay? Next week there will be another question from the final. And we'll deal with it next week. Okay? All right. So you have these all over the place in your notes. If you wanted to combine them all into one page, one location, that would be fine. But if not, I totally understand. But those are the general forms of conic sections. Okay? So a circle looks like that. Okay? X minus h quantity squared plus y minus k quantity squared equals r squared. An ellipse looks like that. X minus h quantity squared divided by h squared plus y minus k quantity squared divided by b squared equals 1. The 2 different forms of a parabola. Remember, the top parabola is an up and down, or up or down opening parabola. The bottom one here is a left or a right opening parabola. 2 different forms for hyperbolas. Okay? Again, top one is left and right, bottom one up and down. Okay? All right? So we got those. Okay? And we've got fun times. Okay. So, how do we differentiate between them? That's going to be the key. The questions this week are going to be, what kind of conic section is this equation? Okay? And so there are 2 really good ways, or there's 2 tells, if you will. Okay? Really, there's 3 total, but there's 2 obvious ones. The first tell is that a parabola, and you definitely want to write this down, a parabola is the only conic that has only one squared term. Okay? So if you have an x squared and a y squared, it is not a parabola. If you only have x squared or y squared, then yes, it is a parabola, and you've identified the conic. Okay? So that's the easy one. That's the easiest of the tells. Circle, I think, is the next one. Oh, hyperbola. The second, I didn't. I couldn't remember what order I did them. Okay? A hyperbola is the only one that has a subtraction sign in front of one of the squared variables. Okay? So if it's x squared minus y squared, or 9y squared minus 4x squared, that's a hyperbola. If the subtraction sign is in front of one of the squared variables, it's a hyperbola. That's the other easy tell. Parabola, only one squared. Hyperbola, subtracting a squared term. Then that leaves circles and ellipsi. And you have to kind of compare them. So we get the equation equal to 1, and the denominators below the squared terms, because we'd have to divide by something, because it's not always going to be equal to 1. If the denominators below that are equal, it's a circle. If they're different, it's an ellipse. Or another way of saying that very same thing is an ellipse has different coefficients on the squared terms. A circle will have identical coefficients just on the squared term. So here are some examples of problems that we are going to have this week. Okay? Later on Wednesday, I'm going to give you maybe one of these exact ones, I don't know, or something very similar to it. And I'm going to say, identify what conic it is, and then graph it. Okay? That's our goal for this week, to see an equation, figure out what it is, and then graph it. Okay? Today, we're just going to identify what it is. We're not going to graph them today. Okay? So, there is one of each up there. Okay? So you tell me which letter is which one, and justify it for me. Okay? You tell me which letter is which one with justification of what it is. What do you got, Eo?
C is a parabola.
Why? Bingo. Okay? So letter C is the parabola. And the reason there's only one squared term. Let somebody else. Give somebody else a chance. Thanks for volunteering. What do you got, Ben?
I'm pretty sure A is hyperbola.
Why?
Subtraction sets the square term apart.
Bingo. Yep. Exactly. Okay. So A is my hyperbola. Because it is x squared minus y squared. Okay? Love it. What else we got? You want to try one?
You got a 50-50 shot.
You got a 50-50 shot. Yeah.
I got it one.
Circling ellipse.
Oh. So, well, it says something equal to 1. So that's not
Okay. So we'd have to get it equal to 1 in order to do that. Yeah.
There you go. D is on the
Eo's shaking you off.
circle.
Why?
Because the 2.
I see 5 terms. So that's just.
I mean the square term.
What about the square term?
I don't know. I don't know.
Eo, help him up.
I mean, I'm not really 100% sure,
Okay.
but it just looks like it could be a circle because all of the variables are, what's it called, like related or whatever. They're all, you know what I'm trying to
It's a circle because x squared and y squared are circles.
No.
Wait, that made no sense.
That didn't make any sense,
Now
but it
that I
was
said it out
close.
loud, it does.
But it was close.
Because of the x squared.
What do you got?
Oh, there's 2 16s.
Nope.
That's-
What do you got, Evan? The X
They are.
and Y aren't the same though.
What they could be.
They're completely.
The squared ones are the same. What do you got for you,
I
Mason?
was gonna say there's a coefficient on B.
On B, there's a coefficient that's not the same as the coefficient on Y squared, right?
Yeah.
Okay. Circles have the same coefficients. So if I put a coefficient here on X squared, it's 1. If I put a coefficient there on Y squared, it's also 1. And what it told me way down here at the bottom was coefficients on the squared terms are different if it's an ellipse. They're the same if it's a circle. Okay? Oops, wrong way. So the circle here has 1 for X squared and Y squared coefficients. This one is an ellipse because we've got 4 and 1 as our squared coefficients.
So,
Talk to me.
never mind.
No, really, what was your question?
Well, my brain was just like, it's just like if you have like a number that's other than like 1 or something like that.
Not necessarily. They just have to be different. Okay? Right? Because I could have written this one down here. I could have made this be, where's my eraser? There's my eraser. I could have put, yep, and that's still a circle because they're the same.
Okay, but then the ellipse is
2 different numbers for the coefficient. Yep. 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 Still a circle there. It just, this would switch then to 2.
So an ellipse will always have a different coefficient.
Different squared term coefficients. Not looking at the linear terms like these two,
Yeah.
okay, or these two, okay, looking just at the squared coefficient. Okay. Love it. Yeah. All right. So, little rehash. Okay. Let's get some equations because it's always good for us because there will be questions like that coming up in the next 3 weeks. Okay. Remember, you only got 3 weeks left. Okay. All right. So, find me the equation of the conics for the circle and the parabola. Okay? Go. You had one too many squares in that. Because it's a parabola, so you should only have 1 square.
I did put 1 square in there.
Okay. It sounded like you had 2.
Yeah,
I thought you had a.
I'm supposed to equal 24, and then
Oh.
the 4 square is wrong.
That was wrong. Yeah.
That's why.
Yep. We'll go over it here right now. Let's do the quick one first. So this is H, right? And that's K. So my equation is X minus H quantity squared plus Y minus K quantity squared equals R squared would mean that we would have X minus 3 quantity squared plus Y minus negative 2 quantity squared equals 4 squared, which is not just your all-time favorite elementary school game, but it's 16. Yes? Okay? Then, on this one, we would say that we've got our vertex over here. We've got our focus over here. So that tells me that it's a right opening parabola. A right opening parabola would be quantity y minus k squared equals positive 4p times the quantity x minus h. A little bit because, oops, this one. This is h and this is k because it's our vertex. And the distance between those two is p. So p here is 6. So this equation would be y minus negative 4 quantity squared equals, bless you, 24, because that's 4 times 6, times the quantity x minus negative 2. You had them flipped around. You had the 24 on the y plus 4 squared one.
Oh, why is that?
Is what you had said.
Yeah, yeah. Wait, why is
Yeah.
that?
Because
That's only up down.
because if I distribute this in,
Oh, okay.
yeah. If you just switch if you just move, so all you would have to do is just move your 24 to the other side
Okay.
and put that coefficient there. Then you're right.
Alright.
Yep. Okay? Love it. Alright? So, now, did I put them on the same slide? Oh, I did. So then I gotta go like this. I gotta go like this. Oops, guess I can't because I gotta go like this. I gotta go there. Want to get them all on once. There we go. Boy! Okay, go for it. Find me the equation of the ellipse and the equation of the hyperbola. Actually, tap the brakes before that. Let me say one more thing about this. So again, circle. So this is the equation of a circle. Okay, I like it. If I look at the coefficients, I'm going purple. If I look at the coefficients, my coefficient there is 1. My coefficient there is 1. So I have x squared plus y squared with the same coefficients. Okay? If I'm looking down here at this one, I've got one squared term, and that's y squared. X is just x, so that's why it's a parabola. Okay? Alright? So all of those hold. Okay, so now find me the equation of the hyperbola and the equation of the ellipse. So if I'm looking at this ellipse, okay, I know that the equation is going to be x minus h quantity squared divided by a squared plus y minus k quantity squared divided by b squared equals 1. I know that because it's an ellipse. Okay? We just got to figure out h, k, a, and b. Okay? So it tells me that I've got vertices here and way over here. Okay? It tells me that I have foci here and here. Okay? So that would tell me that the midpoint between those two pairs is going to be my center. So I've got a midpoint at, or a center, I should say, at 3, 5. Agree? The midpoint of the vertices, -1 plus 7 is 6, divided by 2 is 3. 5 plus 5 is 10, divided by 2 is 5. So 3, 5. Midpoint of the foci, 1 plus 5 is 6, divided by 2 is 3. 5 plus 5 is 10, divided by 2 is 5. Okay. So there's my center, that's my h and my k. Now, that is also going to give me a distance out to my vertice as 4. And that is my a value. That is also going to give me a distance to my foci as 2, and that is my c value. The equation was, for an ellipse, c squared is equal to the absolute value of a squared minus b squared. So if c is 2, that would mean then that c squared is 4. If a is 4, that would mean that a squared would be 16. Oops, excuse me, not 16 squared. It would be 16. And we would need to subtract off b squared. Well, 16 minus what gets me 4? 12. So b squared here is 12. Okay. So the equation that we would have then would be x minus 3 quantity squared all over 4 squared is 16 plus y minus, oops, I'm going to put y minus k there. It should be y minus 5, not y minus k. Y minus 5 squared all over 12 equals 1. Questions, comments, concerns, clarifications? Do the same with the hyperbola. So we first have to figure out what's what. So we've got vertices at 7, negative 3, and 7, 1. Okay. So that tells me right there that it's an up-down hyperbola, which is that one. Midpoint between those two would be my center. So my center is going to be at the point 7, negative 1. Okay. That would also tell me this distance here would be 2, and that would be B. My foci are going to be here and here, and this distance here to the upper one, that's 4, so that's going to be 5. So C here is going to be 5. Yeah. The equation for this one is C squared equals A squared plus B squared. If C is 5, that means that C squared then is 25. If we don't know what A squared is, because B is 2, so that would mean that this would be plus 4. So I've got A squared here being 21. Y plus 1 quantity squared, 4 minus x minus 7 quantity squared all over 21 equals. Yes?